All right. Hi, everybody. Welcome to this webinar about actuator selection. We're going to talk about all things why, how, what, and when. Let's get started. Before we do, though, I just want to remind you of a few things. We are going to be going for about 45 minutes with a Q&A at the end. Make sure you submit your questions in the questions bar. And some tips and tricks, make sure your audio settings are off, see if there's anything eating your bandwidth, and do a fixed wire connection if you can. We will be recording this, so we will send something out to you afterwards. Hey everybody, this is Mia here from Windowmaster Clearline. I'm the sales director, and I'm so excited to talk to you guys about window actuators today. I hope you'll find the webinar insightful, but please do continue to keep connecting with me and our team. You have my contact information there, both on LinkedIn, my phone number, and my email. So let's continue the conversation after today and see what I can help you with. So what we're going to talk about today is window actuators. We're going to talk about the application of them for your projects in North America. We're going to take a look at things like what is it, how does it look, how do window actuators work, what's required to make sure that they work really well. Then we'll dive into some of the product ranges that we have for UL and non-UL listed products for Windowmaster. I am also going to take you through a free tool that we have on our website called the Actuator Finder, which I hope you will find really, really useful. Then I will wrap up with some things about Bms integration and practicalities. So stay tuned for the whole thing if you can. So what is a 24-volt window actuator and what is it used for? Typically, 24-volt window actuators are used to automate a window or vent solution. In layman's terms, that means putting a actuator unit on a operable window or vent to make sure that it can automate the movement, meaning open or closing of the window or vent. This can be in an intelligent way through Bms integration, or it could be through a simple keypad operation through the touch of a keypad. We can also even make it more sophisticated through millimeter controls of sensor inputs, and I'll get to that also in the end. This is used for Windowmaster in lots of different applications, both for natural ventilation, but also for mixed mode ventilation and smoke ventilation. We can also use it together with our system to control sun screening, cooling, heating, lighting, and mechanical ventilation. But let's get into some of the things that it's really used for. So in North America, window automation is typically used for what's called natural ventilation. Natural ventilation, here just to provide some context, is using the outside environment and bringing it into a built environment. That could be through, again, just a simple open close of the window with a keypad, or it could be using sensors and algorithms to bring this outside air in intelligently. What it also can be used for is something called mixed mode, or you might also hear me say hybrid ventilation. Now, if there's some mechanical engineers listening in today, they might say, well, Mia, mechanical or mixed mode and hybrid ventilation, those are maybe a little bit different, but today I might use them a little bit interchangeably. If I talk about mixed mode or hybrid ventilation, I'm talking about using natural ventilation at certain times of the year or days or months, and then at other times using a mechanical system. So those are great solutions where natural ventilation is used through using window actuators. Now, I get another question quite often, which is, well, Mia, natural ventilation, you can also do that through just a manual open close of a window. And that's absolutely correct. That is the basis of natural ventilation. But here today, we're also going to be talking about it because it's being used in an automated sense, meaning here we are using it in a reactive, demand-driven ventilation approach. And the reason for that is if you leave it up to a building occupant to go over and open and close a window all the time, then again, you're leaving it up to the building occupant. They have to make the decision to actually go over and open the window when they feel the need. Here, if you automate the use of natural ventilation, you don't have to consider the building user having to have to be a part of that interaction. They can through building control of a keypad. So they can have some level of control, but it's really effective to automate natural ventilation because it allows this system to work for the building occupant without them even knowing. So it's also a indoor climate control system. And if you use it for cooling, like a conditioning, that is also, of course, something that the building occupant won't have to consider. But here today, we're talking about everything automated. So another great application for using window actuators, especially in the North American market, is to use it in a heat and smoke application. Here I'm talking about using an actuator and our control panel as part of a full fire life safety system. Our controllers and our actuators won't be based off of Windowmaster scheduler. It'll be connected to a notifier system. But our parts, the actuator and the controller, would be parts of the full system to allow smoke and heat egress. So a lot of our products are UL 325 certified, and that means it could be combined together with a UL approved notifying system to allow a way to open the building up in case of heat and smoke in a project. So that's another application as well. Another application that I actually don't think that is talked enough about is the use of window actuators in a ADA requirement, so an American Disabilities Act. If you have a window that's really heavy or it's too high up and you have a project where you have certain rooms or zones where you have to have a operability condition for everybody, using a window actuator on a specific window is a way that you can also comply with ADA. And I've got a great ton of projects I can share with you guys if anybody is interested, and also seeing some examples for that. Now, what type of projects are we typically seeing window actuators and window controls being used in? Here, because the primary application is usually natural ventilation or, again, a heat and smoke type of application, we're seeing it in these bigger projects. Now, that's not to say that a small project, a small building can't use window actuators and can't use natural ventilation, but I'm typically seeing it in education projects, being K through 12 or higher ed or community colleges, shopping centers, cultural facilities like museums and community centers, of course, commercial and office spaces, healthcare like your visitor center or the welcome part of the building in a healthcare facility, and also a sports facility. Now, these look to be all new buildings, but please keep in mind that window actuators and natural ventilation is also something that can be effectively used in retrofits as well. And I'll get into that a little bit later too. So now we're going to start to really get into the nitty-gritty of some of the details here. I really want you guys to also get a good understanding of what kind of systems you can use window actuators for. So I've penciled out the various different type of window or vent configurations that we typically see and that we have a solution for. So going from left to right, you have your traditional awning style window. You have a casement style, or a side hung as some people also call it, a hopper window, a skylight, a pivot, and I'm also seeing more and more of these parallel pop-out windows where the scissor hinges are used to bear the weight, and then the actuators are either placed horizontally, vertically, or both to move and push the parallel window out and in. So these are the most often used applications. Now, that's not to say that some other sophisticated design cannot be also applied, but these are the most common applications that I see in projects with window actuators. Now, I want to quiz you guys a little bit because this is also a webinar. Unfortunately, I can't hear your answers, so I'm just going to trust that you'll take the time to maybe think about this a little bit. But I wanted to add a little question in here, which is to get you guys thinking about, look at these images of the window configurations. Can you think about for a few seconds what window type that I haven't listed here that's pretty normal in a building project? So which type is not listed here? I'll just give you a few seconds and then I'll take a sip of water. All right, so some of you might already have, yeah?
Yeah, actually, you actually had some great responses. Very quick to the drawing questions, Mia, and they say sliders. Are they right?
They're sliders in some sense, like a single or a double hung is a vertical slide window, right? So that is the typical type of application that we don't have an actuator, and I haven't seen a solution for that in the industry. Now, again, that's my perspective. If you guys have a solution for that, love to see it. But that's typically not a solution that we have. So if you have a design, try to use some of the typical styles that I have shared on the screen and maybe stay a little bit away from either a single or a double hung window, a sliding window, yeah. All right, guys, so good. I'm glad you guys participated in that one. Thanks. Now, here's some great examples I have on these pictures about real life projects that we've worked on. If you follow along with me, follow your eye up to the top left, you have an awning window where you have a surface mounted type of installation where you see the actuator right there on the fixed part of the frame connected to the operable part of the sash and is opening and closing that awning window. And if you take your eyes one to the right, you can also see a hopper style here. Again, this is an inward projecting hopper wood window. And this is a nice concealed solution where they've actually concealed the actuator into the wood frame. Some other examples, moving more to the right, you have a skylight here with these chains protruding out and opening the skylights. And then here, one more to the right, you can also see another type of concealed solution where you actually can see the chain actuator sticking out. We have two actuators on that window, and it's also concealed within the wood frame. Might be a little difficult, the one here to the very right, but if you do notice, there are some spindle actuators sticking and protruding into the space here, and the reason we've used spindle actuators is due to the heavy weight and the load. So spindle actuators are also something I'll elaborate a little bit more on later. But great projects where here, just the yellow one too, if you were interested in the parallel pop outs, you could see the scissor hinge here, and there's a chain there that holds or that does the operation, the actual pushing. So I will get into the whole concealed versus surface mounted approach as well a little bit later, so stay tuned for that, but just wanted to get you guys thinking and understanding this better here up front. So before we talk about concealed and surface mounted, I want to just introduce you a little bit to these devices called actuators. Now, again, some people might also call these devices motors. Actuators, motors, same thing, at least in most people's cases, but typically I use the terminology called an actuator. And these are all low voltage actuators, so 24 volt DC. And if you take a look at here, this actuator to the very left, it's called a chain actuator. This is the most typical application that we'll use in, let's say, 90% of our time. We'll use these chain actuators, and they come in lots of different sizes and colors and force capabilities, but they look like this in a nutshell. You have a housing, and then you see the chain sticking out a little bit there. Now, if a window manufacturer or a glazer has done a little bit of mock-up testing on their window and they have decided that for whatever reason the chain actuator is not doing enough locking capability on the window, then we also can see window locking actuators as an addition to the chain actuator. So you'd use a chain actuator and a locking actuator together to provide additional locking capability. So that's another actuator that can be found in the industry that you can also use to provide additional locking capability. Now we have louver actuators as well, and then like I showed you a picture of earlier, there's also spindle actuators. Spindle actuators are great for force, and they're a strong animal, but they also do protrude into the space. So a great application for windows that are very high away, not necessarily always the most aesthetically appealing, but good for very, very heavy windows, especially skylights where there's maybe snow or ice load. So most of these are UL 325 certified. There's some of the locking actuators that are not, and also the spindle actuators are not, but we will of course guide you through that for your specific project outline things as if this is not UL or this is UL. But all of our chain actuators are, so that's also why most of the time we are using these chain actuators in a majority of our projects in North America. Now, if you guys have never seen a window actuator, never taken it apart or even considered what this thing looks like on the inside, I've put an image here to the right where you can get a nice little visual. This is one of our actuators where you can see a nice slim housing on the outside, so the actual actuator housing. And then here on the inside, you could see the chain and how it kind of folds in on itself when it retracts into the house of the actuator. You see the actual chain here as well. And there we have the gearbox and the motors to make the chain open. And then of course, what's also in these actuators is the electronics, the PCB boards to actually provide the intelligent movement of the chain in and out, and also the speed. So this is a chain-based actuator that you see here. Now, to get you guys thinking a little bit more, I've shown you some actuators. We've talked about the different window configurations. Now, to make an actuator work, you know, it's not just the actuator. You have to use a control panel or some kind of power supply to that. So I've inserted just a very simple connection diagram here. You see the window frame. This is a awning type of window where the actuator is surface mounted onto the fixed part of the frame and also connected to the operable part of the sash. What you might also notice is that, of course, there's the cable. Again, these are low voltage units and they do have a cable. Most of the actuators that Windowmaster provides has a pigtail cable with it when it's supplied, and they come in different lengths, and we'll talk about cabling in a little bit as well. But you see the cable run, the connection of them, and also the cable running along the frame in this image, and then being connected to this device called a motor controller. And a motor controller is a control panel. It's a unit that provides these actuators with their power, but also their control signals. So we'll continue to talk a little bit about that. What I also want to highlight here is that you have this motor controller and it's connected, or it can be connected to a building management system or a building automation system. You could hardwire it in, but we actually have very fine intelligence to also be able to share information through Fieldbus Communication. So we have various different types of Fieldbus Communication, which allows you to get a lot more detailed information about the actuator, not just is it open or closed, but also things like what is the percentage position opening of the actuator? What are the speeds of the movement of the actuator? Is there any fault indication in this actuator? Are they synchronizing as they should? This is all due to, of course, a sophisticated intelligence with the building management system, but also through a two-way communication technology from the actuator to the motor controller. It's not just this motor controller sending these actuator signals, it's a two-way communication. And that's also important to consider here, guys. You have, your use of the actuator, but also think about, well, how is this being connected further on? Really, what is the aim for wanting to use the window actuators in the project that I'm working on? Should it just be simple? Do we need more sophistication? What kind of readings do we want for the actuators? There's a lot of intelligence that you have the capability to be able to use in your projects. But moving along a little bit here, we've already talked about this. You see an actuator connecting it to this device called a motor controller. Here's just a better image of it. It's a box, and it has the capability to do all of these neat features that I mentioned already below: positioning, reverse functions, synchronization, and speed differentiators. So to get you more detailed information, just a little bit about these actuators. I'm not going to go into the nitty-gritty details of this. You guys can also look at this afterwards. I will share my slides. But the idea here is that you can also get an understanding for that there's a wide range of actuators. So there are different type of actuators. They come, as you can see, in different colors. They come in different what's called chain stroke lengths, so how much chain is actually in this device. And the differences in the chain and the length of it also equal distances or differences in the distance of how much the window or the vent can open and close. And what you might also notice is that there's differences in the pressure force. So if it's an awning window, that means like how much this actuator can push. The traction force, how much it can pull in again, and then locking force capability. We've also talked about that these actuators are there to also help close the window and lock it up. Sometimes we need a little bit more, but that is also something that's recommended to finalize during some kind of mock-up or test. And what you might also notice is that there's also differences in these devices or in these actuators in terms of their size. So they have differences in length and in width and in height. And that is really where also our team comes in, where we help you guys understand what the right actuator is based off of the information that you give us. And then just to wrap up here, you'll see all of the actuators are 24 volt, and all of these small ones at least are 1 amp. And then outside of that, there's also much more stronger actuators. So sometimes we need a wider opening degree of our windows, or we need a really strong actuator to be able to push a window or a vent open much more. So then we go into these other categories called a medium or a large, sometimes even called an elephant actuator, because they're so strong and so large. So same thing here. They differ in the different type of colors that they come in standard, the change stroke lengths, the pressure force, the tractive force, the locking capability, and the size. And check this out, guys. Like here, the size, right? Look at this is one of the largest category of actuators that Windowmaster has. And just check out some of these sizes, right? They start to get really, really big, but the reason the size of the actuator also goes up is because you have a very long capability in terms of a change stroke length. So that's a very long, opening of a window, and that chain needs somewhere to go, and it's also much thicker. So that means the body of the actuator gets longer and it also gets deeper. But, this is something where our team has a high level of expertise. So this is something that we'll talk you guys through as we're working with you on a project to really get you to understand what this actuator will be on your window, what it will provide, but also how it'll look. And then last thing here, you'll see the current also changes a little bit in some of these really heavy actuators. Sometimes they can go up from to 2 amps, and even some of them have up to 5 amps. So there's a wide difference there as well. And then what I also want you guys to understand, as I mentioned earlier, is that we have these actuators and they need to be connected to a control panel as well. It's not one control panel to one actuator. We have different type of control panels that allow you to have many actuators be put and controlled on one control panel. We also have a lot of different capabilities in terms of how many groups you can do of windows together, how many rooms you can put on one control panel. But what I really want to emphasize here is that these control panels, and from Windowmaster's side, they're called WCC motor control panels, is that the largest control panel that we have, that one can do up to 20 amps, and most of our actuators are 1 amp. So if we just look at it high level, that means our largest control panel can handle up to 20 actuators. But then that also has a variance in how many groups you can do, which is what we call motor lines, and how many inputs, which are things like switches and sensors. So don't worry, guys. This is also where our team at Windowmaster helps you guys to figure out how many control panels that you need. But I just want you to understand that they come in different sizes, and then they also come in different capabilities. One thing that I also want to mention about our control panel is that they have distance limits. So you might see in our installation manuals for these control panels is that they have variances in their distance limits for how far away they can be from the furthest controlled actuator. And that actually depends a lot on the gauge size that you use for the actuators. It also depends on the amp consumption of the actuator. But high level and in a general guidance, I would say don't put the control panel more than 150 to 160 feet away from the furthest away controlled actuator. These control panels can typically be located in a place like an IDF closet, an IT room, a mechanical room, a storage closet. This is really something that together as a design team, you talk about also with your electrical contractor, where do you have space, and then you take it from there. Size-wise, they're about 1 foot wide and 1 foot tall and about 3 inches in depth, so they're not too bad in size-wise either. But they have capabilities to do different motor lines, different amount of amps, then they have their distance limits. And then the last thing that I want to mention is that they also come in differences in regards to if they need to be integrated to a building management system or if not. And again, we'll help you guys kind of figure out what's the right one and how many you need. Now, let's get to this tool that we have on our website called the Actuator Finder. This is a free tool that Windowmaster has developed on our website, which helps you, as the name sounds, to find the right actuator for your project. This is a tool that can help you with that, but also a lot more. So let's try this out together. So I'm going to go on Windowmaster's website, and that's just windowmaster.com, and then find the Actuator Finder. And then we're going to start to put in some inputs here. Now, what you might notice is that everything is in metric. Not to worry though, there's a really easy, if you just type in Google inches to millimeter, you'll get this free converter up that's really easy to use. So let's try something together. We're gonna use a side hung window in this project. Again, I'm gonna do facade windows, they're not roof windows. But again, you can see here, if I chose roof windows, how that changed this over here. So I am going to use a facade window. I'm going to be using a side hung, i.e. a casement window. I am going to have, my casement is going to be 60 inches in height. And then I'm going to say the casement is about 30 inches in width. So there, you see how those changes also gave you a different change in the image. So you can already see that this is just initially suggesting that you have 2 actuators on this window. I'll tell you more. Last thing you want to input as well here is the glass thickness. Now, if you guys ever are confused about what this all means, you could see the little question mark too. That should give you some elaboration. But in this this example here, I'm going to say my windows are dual pane glazing. Each of the glazing is about 1/4 of an inch thick. 1/4 of an inch is about 6 millimeters. So I'm going to say total we are 12 millimeters. This glass thickness is only the glass thickness, no airspace or gas space in between. So just the total amount of the glass together. And then you'll see here the casement weight. That's of course just the input from these here that's coming out. And then one other thing too I want to show you guys is that this is interesting because this also starts to tell you a little bit more about the tool. This is the ventilation area. If I want to calculate also with the triangles on the side, because what you'll see is you'll get information about your geometric free area too, then you choose this one. I'm just going to stick with the rectangle below. And then before I hit find actuator, I'm going to also open up this advanced settings because it's got a lot of really nice features here for me to be able to tell the tool more about the windows that I'm using. So first thing that you'll see here is you have your opening requirements. I have chosen to say, well, I want to find an actuator that's based off of how much change stroke I want. And here I'm going to say I want a 400 millimeter, which is about 15 inches of change stroke. Cool other little feature you'll see here is that the max possible stroke is also outlined for you. You can't do anything about that, but that's just telling you based off of your input that you've given up here, and this is the max change stroke length, Mia, that you can use on this actuator that you're trying to find. So, okay, 400 millimeters. And then notice here to the left, you can also change if you know differences in your mounting conditions, your frame sizes. You can also change these as well, A, B, and C. And again, if you don't know what they stand for, you have, of course, the visual up top, but also a written description of that. So feel free to also change the mounting conditions here for how much frame you have. I'm going to leave it at standard. And then before we go to find an actuator, the last thing here is to look at these other requirements too. So the mounting of the actuator, I'm going to say surface mount. Do I have any fire test demand? No, I'm going to leave that as is. Do I have a number of actuators? I recommend that you guys leave this at the calculated amount. Don't choose it yourself because really this tool should tell you how many actuators you need. So leave it at the calculated. And then the same for the forced actuator. I recommend you leave it at the calculated, but if you have a favorite actuator from past projects, you can try to see if that will work. Of course, you can force to see if an actuator will work, but I'm going to leave it at calculated. So let's see here, find my actuator, cool little system. All right, so this is the output that you'll see. It's telling you to use the WMX826 actuator. Fantastic actuator. What you'll also see below is that you have a change stroke length. Of course, that's the 400 that I gave as an input earlier. The system is also telling you how many actuators to use, your pull and your push force, and it's actually suggesting what kind of brackets to use for your mounting capabilities. Now, a cool feature that I said to you earlier, it's not just going to tell you actuators, it's going to tell you a lot more than that. There is here also telling you your estimated geometric free area. Again, this is in meters squared, but if you just highlight it, copy it, and you can do the same thing for the inches to millimeter, find from meters to square to square foot, insert that in, and here you go. You'll get it in square foot for your North American calculation, or at least in the US. I know Canada sometimes uses metric. So there you get a geometric free area too, and an estimated opening degree. And then last final really cool thing is this download section. So here you guys have clickable links to be able to get CAD files, PDFs of the actuators. We even have BIM objects there for you, product data sheet, installation, which are general installation instructions. And then one of my favorites too is the 3-part spec. So you can click on this and you can actually download a Word version of our 3-part spec that you can use for your Division 8 to slide into your project bidding section to be able to understand or to describe how this actuator and how the system should work for your project. So use those clickable links. And then last thing that you could do here is, of course, you can save the information. So if I click Save Information in PDF, I get a nice little PDF down here, and you guys can save this for your project folder to have something to refer back to. You know, these are all the inputs that you gave earlier, or I did. And then the clickable links again. And then if you guys ever want to, there's actually the URL here. If you want to get back to this calculation here that we have, you just use that URL code and get right back to the Actuator Finder, and you can fine tune and make adjustments. So this is nice for you to be able to save for your projects as you're kind of developing on. And then you can also, of course, click Get an Offer. It'll go right to our team, where we will help you guys to get, of course, pricing and budgeting for this specific actuator. Before we do any kind of pricing, of course, our team will triple check that what the Actuator Finder gave you is still the best solution. So we will take our review of it as well. So that's also what this disclaimer says is, you know, this is a tool. It's a tool for you to understand actuators better and to get an idea of what you should be using on your windows or vents, but still, at the end, please contact a Windowmaster specialist to help you understand if this is the right solution for your window or your vent before you slide it 100% into the final specification section. So that is the Actuator Finder. I hope you guys will enjoy that tool. I've also put the steps here in my slides. So again, I'll send my slides out afterwards, but here's the steps if you guys want to refer back to that afterwards. So I hope you enjoyed the Actuator Finder. I think it's got a lot of really great things for you all to think about. But there's also things that the Actuator Finder doesn't necessarily say. So this is also why it's good to consult with a Windowmaster representative after you've worked a little bit with the Actuator Finder, because there's things that we also have to take into consideration for your specific project. Maybe some of the obvious things, or at least that I think sometimes I've seen more and more of that people think about, is of course, you know, the technical capability of the application. What are you actually using this actuator for? Again, think about that. Is it for an ADA? Is it for hard to reach windows? Is it for natural ventilation? Is it for cooling and conditioning? Is it for a smoke application? Think about that. Do you have a cost-effective perspective as well? Do you want to think about that? Also think about when you're evaluating different actuators, always think about the quality and the reliability, ask to see testing and warranty information. Also think about how these actuators should be installed. We'll get into that here soon. And of course, the aesthetics in most, especially in the architect's perspective, is a really important thing. So how are we going to make sure that this device or this actuator looks really good on the profile? Now those, there's also some other things that are definitely not obvious, but these actuators, they come with different speeds, which also means different noise levels. So think about, you know, do you need to be specifying these actuators that have to be really, really quiet? Do you guys want these actuators to integrate to a control system? Do you even further than just integrating to a control system, do you want it to be very, very sophisticated to also ensure that they have these micro adjustments to be able to prevent things like draft or overcooling? Do you want to also make sure that you can find an intelligent way to make your design really sleek? Like if you have adjacent windows, do you want those adjacent windows to be able to move at the same time? And then things like, what status updates do you want from the actuators that you're specifying, or do you want status updates? Things like, you know, what its position is and what its speed is, and do I have any fault indication? And then there's also things like having pressure safety function, like a reversing technology. Do you want that in the actuators? Items to also help prevent the seal of the actual window of the gasket. And you also want a capability to retract from fire and rain. So lots of things to think about, but also something for you to consult further with when you're talking to a representative. Now, we're going to get into the practicalities of it. Before I talk very, very specific things, I want you guys to understand also for our North American market here, Windowmaster Clearline, for every project, we do project-specific wiring diagrams, electrical wiring diagrams, and we also do shop drawings for you. So these are shop drawings where we help and detail for you with all of the important details, like where do you put the brackets, how much do you space it out, what kind of screws do you need, the dimensions of them, what is your, not only your chain projection for the window or vent, but what is then also your clear opening. So taking the frame away, so we have a little clear opening diagram. What's your bill of materials, your whole list for your project. This is something that we do for every project in North America, and I'm happy to share an example with anybody in an email. So send me an email if you're interested in seeing a sample of a shop drawing set as well. That's, yeah, important also to understand that we help you detail this out and that you're not completely alone in understanding the installation. But in the meantime, before, you know, Windowmaster Clearline helps you out with doing specific shop drawings, you can also look at this a little bit on your own if you'd like. We have CAD files on all of our actuators and all of the mounting brackets on our website. So take a look at the CAD files where you can see the dimensions of all the mounting capabilities that there is available for the different actuators. But again, consult with Windowmaster if you have any questions. We're always happy to take a look and give you maybe just an initial show of how the brackets would sit on your specific project before we do shop drawings. So talk to us about it too if you have any questions. Okay guys, so I said earlier I was going to get into this whole surface mounted concealing. It's an important topic and it also has a lot to consider. Aesthetics are a big deal, and as they should be for building projects, but These actuators, we have lots of different options for you guys and lots of different ways in which you can make it aesthetically appealing for your project. Now, some of our actuators that we can provide, actually, as you can see in the image to the right, can physically be concealed into a frame. That's a great way, as you can see on the image, to try to provide an aesthetic solution for a window or event. But it also has its downsides. How are we going to get the actuator out if we have to service or maintain the actuator? And what about if we have to replace the actuator? Do we have to then also take the frame out or anything difficult in terms of getting screws out? Just really think this through in terms of service and maintenance and potential replacement as well. So there are also other things to consider about concealed actuators. Now, there are some actuators that are available in the market, and especially the ones that Windowmaster provides, which are very sleek and slim and are a beautiful way to actually get an actuator into a window frame. But this really has to be discussed early on, not only with the glazer and with Windowmaster, but of course also with the window manufacturer. Because if putting a window actuator, a concealed window actuator into a frame, is that going to cause any production challenges for the window manufacturer, lead times, cost? These are all things to consider when trying to think about, do you want a concealed solution or a surface mounted solution? And another example that I have for you guys, which I think is also valuable, is that instead of using a concealed actuator, consider using, as you can see here to the image to the left, a surface mounted actuator, and then adding a cover cap on it, because that allows it to easily be unscrewed, taken off for potential service or maintenance or replacement in the future. You can see the image here to the right, how that looks, nice and beautiful and concealed in quotation marks, right? But one thing to consider here as well, which I hope that my designer will be happy that I mentioned to everybody, is that if you are using some of the larger actuators where the brackets need to pivot a little bit when the window is opening, we have to make sure that the cover caps have enough space for when the actuators do a little bit of pivoting with their brackets. We have to make that and take that into full consideration when we're designing these cover caps. Some other examples here for you guys to consider. Again, I'll send out the slides so you can take a look at this a little bit more in detail, but there's lots of different ways in which you can conceal and try to find some caps without it being actually into the frame. Another way to provide a great solution instead of doing a concealed solution is, of course, to provide the actuator to be the same color of the frame so that it's not such an eyesore. You can have the actuator in any color that you want. I just need to know the REL color, so the RAL color that you want to have. But then I also need everybody to understand that with anything custom always increases the cost and it always increases the production lead times. So making sure that if you want something very specific and custom, like a specific green or pink or whatever you want, make sure that you put that into your specification section in your Division 8 early on so that the bidding glazers can see that early when they're providing their bids to your project, and that they understand the of course, financial and the time implications of that. So just think that through a little bit as well. Now we're getting to the end here as well, but I want to wrap up with something about the cable and the service and maintenance. Now, cable is also something we get asked a lot about, and cable is something that we need to be consulting, of course, with the electrical contractor about, but also, of course, the window manufacturer and the providing glazer for your project. But take it to the left here first. First, think about, well, where does this cable need to go? All of the actuators have to have a cable because they need their power and their control signals. So you have to think about cables. Are they going up? Are they going down? Are they going left? Are they going right? Are you going to be using some kind of mounting clips? And how are you exiting the window? Is it going to be going through something? Are we clipping it around? What's the exit point also? Where is it going to? Is it going to a junction box? So really this is something to consider a lot together with the electrical contractor and their requirements that they have for the wiring and for the cabling. They might want to use cable trays. They might want to use conduit. There's a variety of different things that the electrical contractor is thinking about that we need to coordinate a little bit also. And that's also good to put into your electrical documentation so that everybody's aware of how this should be. And then think about too, you know, if we're doing holes to get through the mullion or to into the frame, do grommeted holes, and then think about kind of capping as well. Is that going to be color matched? There's really a lot to consider here, and we've created just a very simple image here to try to get you guys to understand. As you can see here, this is an awning window with a surface mounted actuator, and then the red cables going through. Are you using grommeted holes? Are you considering also the flex of the silicone in the cable? And then also, where is that going? Are you taking any burrs to consideration? And if you are putting clips here, how is that also going to look? Are we using some nice smooth clips? Or are we moving? Are you maybe using some more rectangular, some rigid clips? Just again, all these things to try to get the visual aspect in and the aesthetics as well. And then last point here, guys, is that service and maintenance, always get a lot of questions about that as well. Now, from Windowmaster's perspective, all of our actuators are tested in our production in Germany, and then they're also lubricated before coming to our North Wales facility in the USA and distributed out to our projects. But to ensure that your actuators have high quality and functionality throughout its lifetime, we recommend to look at the actuators a few times a year, that your facilities team maybe takes a damp cloth and just dusts away any dust or debris that's laying on the actuator and that potentially could get into the chain. That's also anything in regards to lubrication. They shouldn't need it, but if you wish, I think also going back and doing a lubrication, at least the window hinges as well, making sure that those are lubricated a lot along with the chain so that everything is just moving as smooth as possible. One thing I do also recommend, if you're using actuators in a heat and smoke project, those probably or hopefully won't be used, right? But we still want them to be really good in the potential for a fire situation. So maybe testing it once a year and just making sure the actuators are moving really smoothly. I think that's always a good thing to do. And then from Windowmaster Clearline's perspective in North America, if you do have a concern and you'd like to have an annual service check for your project, that is absolutely something I'd be happy to discuss with you further. We can get an annual service agreement written up for your project where it outlines, you know, us coming and checking all the actuators, checking the controllers and the keypads, and making sure everything is working as is. But a lot of these technical questions or any kind of troubleshooting, a lot of it actually can be handled very effectively over a FaceTime or a video call. I know it may seem a little silly, but a lot of things actually can be shown, and we can really help you a long way there. But we take it per project, and our team is here to help you guys along the way as well. So that is what I had planned for you guys today. I hope you are leaving here today feeling like you are the window actuator master, and that you feel a little bit more comfortable with using actuators in your project, and ready to take it on in an effective way. But as I mentioned earlier, our team is here to help. So we have a West Coast office and an East Coast office. There's the phone number here and the email to both of those offices, and we are always happy to answer any of your questions, any of your comments, any of your concerns. Our team is here to help, of course, also to provide you with a product suggestion and an offer, but also just general inquiries and inquiries. We're here for that. So contact one of my colleagues, but also feel free to contact me again. Here is my direct contact information. Please link up with me on LinkedIn. I love to follow you guys and see what's going on also in the industry, and I hope that we can continue to share information there, but also give me a call and send me a direct email there. That is what I'm here for, and we will hopefully help you with all of your questions that you have for your specific project or just in general. So that's it, guys. That is what I had for the session. Just to wrap up, for you guys to just get a little familiar too, Windowmaster is our mission fresh air, fresh people. I really appreciate you guys listening and taking the time out of your day today. I know Zoom and webinars, it's heavy. There's a lot of things going on with us sitting in front of my computers. So I thank you so much for being here today, and I will take it over to some questions now and see if we have any questions in the chat. And if not, you're always welcome to get questions afterwards. All right, Laura, let's see here what we got. All right, everybody, nice questions. Sliders. Okay, so one of the things I had from Steve, he asked, is it a simple manual operation possible? By manual, I mean something like a wired switch or a wireless remote. Absolutely. So Steve, I've talked a lot about, you have all of this intelligence and integration, but absolutely, we also see that in projects where, like the ADA application, but it could also just be, you have a warehouse and they just want all of the windows really high up, and they don't want to use a pole. They just want to have something that they push a button when they want to open the windows. They being like a facilities person or somebody who works in the place, and they push a button and then all of the rows of windows, they of course automatically open. And that would be just through the simple touch of the keypad next to the windows. And then you would still want to have a power supply, so you'd still use our WCC and our actuators, but then you would also just have the keypads, and then that would be it. No building management system integration or automation or sensors. It would just be through those devices, actuator, brackets, a control panel, and then keypad. So that's also very normal, and we see that in quite a lot of projects. All right, Jesse, you asked, do you recommend a heavy duty screen in addition to the entrapment protection? I mean, that always depends on, the specific project, right? Let's say, for example, we are working on a project. We're about to deliver the units to a correctional facility, so a prison where they have screens in front of the windows, like from the inside looking out. They have screens to ensure that nobody can get out of the windows. So those would be a very heavy duty screen, but maybe you're also, maybe I also get questions about like bug screens and insect screens. That's a more low way to ensure entrapment protection. But and bug screens, by the way, are often used in projects, and we do have brackets that we can supply to where they will the screen will just sit neatly on top of it and allows the chain to go through. So we have solutions for bug screens as well. One thing I will say though, if you are using bug screens, I hope my building performance engineering team will champion or say yes to this, is that if you use bug screens and it is for natural ventilation, of course, think about too that bug and insect screens, the more porous they are, of course, that differs in the airflow rate as well. But we have solutions to work really well with the actuators and bug or insect screens. So it's just project specific, Jesse, but entrapment protection, at least on the actuator side, they should be able to handle a lot. We can also limit how much the opening should be, right? Like I gave you all an example earlier where we used a 15-inch chain stroke length. If you have concerns about entrapment protection and risk, in the New York area, for example, we're not allowed to open the windows more than a 4-inch clear opening. So that could also be a way to think about, entrapment security concerns, is that you limit the opening to how much the motorized windows should be. And therefore we of course will limit the chain stroke length of the actuators that we specify and we supply you guys. That's also something that can be configured on the control panel that we supply. We can limit the percentage of opening. So there's lots of solutions to help with any kind of security or entrapment concerns. But of course, if there's anything specific, Jesse, in your project, you shoot me an email and we can always talk about that. I think that's it.
Yeah, maybe you could also speak a little bit to some of the key features or technology that's really helpful when you're placing window automation in a school, for example?
Mm-hmm. So what's important in a school is to think about, of course, you know, maybe take the first thing. What's the aim of it? Is it to provide an ADA application in a room? Is it to provide fresh air within the building? Or how are we using the actuators in the school project? Let's take the example that the window actuators are being used in a school project to provide natural ventilation and fresh air into the space. Well, the way that we work with that is that our team will ask about, okay, well, fantastic, you're using it in natural ventilation. Well, what is your required opening degree or approximate opening degree of the windows so that we have a good air change rate within the room? And that allows us to be able to specify how much a chain that the actuator actually should have. I have a little actuator actually here in front of me. Maybe I should have shown you guys that a little bit earlier, but you'll see that these actuators, they can come in lots of different chains and lengths. And then we talk about what one you need for your school project to provide enough fresh air within the space. Specifically for school projects, Laura, kind of like to Jesse's question earlier about entrapment protection, one thing to also consider for school projects is that if you have windows that are below 8 feet from the floor, that are automatic that you want to use actuators on, just consider if you want them to have a limit to how much they are open. To ensure that there's no risk of children falling out or, you know, reaching the actuators, things like that. That is something that also should be considered in, and especially those scenarios where children could be in reach of the automated windows. Are we limiting how much the window should open so there's no, you know, security concern about the children falling out? Again, should we add a cover cap so that no child can do what I'm doing now, like, you know, picking with the actuator, touching things, etc. So there's a lot of things to also think about in terms of the occupants within the space. Are they able to reach that? I always recommend, if we're early in design, get those windows up 8 feet from the floor. Then you have a lot less to worry about. And also from an airflow perspective, it's also nice to have the windows high up because then the cool fresh air flows and spills into the space and distributes more evenly. So that's just get it 8 feet up, and I think you're in the clear with a lot of potential concerns and also good design as well. And another thing to think about with school projects too is this, of course, how are we designing it? Are we combining it with a building automation system for the school that maybe half of the year the natural ventilation is to be used and then the other half you have a mechanical system? So how are we making sure that those systems, they interact, or is there an interlock system so that the natural ventilation is not going when the mechanical ventilation is going? Again, we also want to conserve energy and making sure that there's not an overuse of both of those in a space. So there's a lot of things to consider for school projects, but we've worked on a ton of them. So we have a lot of experience also to help you guys guide you through those steps, and also to specify it, to show it in your drawings. You know, specifications and drawings for using window actuators is a whole nother webinar in and of itself. And we are going to create some content for you guys for that. But I'm happy to share examples also with you guys if you send me an email about specification sections, things to think about to put into your drawings. So send me an email there too, and I'm happy to talk you through it as well.
That was really, really good, Mia. And I think one of the nice things that you touched upon there, I mean, you touched on a lot of really important considerations, but you also spoke a little bit about the BMS.
Yeah.
A question that we often hear in the other markets, like in the UK, for example, that comes up quite frequently is about the BMS. Like, how do we know when the windows should open and when do they close, and what is the communication process between the window automation and the BMS? Can you speak a little bit to that? I mean, that's important for all building types that we're working with, right?
Yeah, it absolutely is. BMS integration, if you are going to have that, is a crucial part that's designed out. Again, the mechanical engineer can speak to this probably much better than I can, but you have your riser diagrams in your mechanical sections. So creating really good riser diagrams that shows, that you have a window control system and how the integration to the BMS will be on a modular scale. In most applications where there's BMS integration or BAS integration, is that is done through what's called Fieldbus Communication. So we take the control panels that we have that are 120 volts, and then we figure out together with the mechanical engineer what type of Fieldbus communication protocol they are using for their building management system. And then we specify a little card that's physically inserted into the control panel. And that allows this control panel that again sends this actuator with the power, but also the control signals. So our control panel integrates and speaks to the building management system through the preferred Fieldbus communication. In North America, BACnet IP or MSTP is most often used, and we absolutely have the capability to communicate through that type of Fieldbus. In Europe, KNX is used a lot, or LAN or Modbus. So if that's also the application, we can do that as well. If your project prefers not to use building management system, would just rather hardwire right into an output, that is also capable. But I want to just also underline that if you use the Fieldbus communication, you have a lot more intelligence in what can be sent to the BMS. Fieldbus communication protocol gives you the capability to send more information about the actuators, about specific things like what is the actuator's speed, what is the actuator's position, closing and opening position, what is the actuator's, does it have a fault indication, is it synchronizing really well if we have like two of these together on a window, and what is the actual status of the actuator. If we just do a hardwired connection to the BMS, you're gonna get it's a simple switch, right? So it's just open, is the window open or closed? There's not much more to that, and that's often used in a fire life safety system, and that's great because that's what that type of system design, it just needs to know, are the motorized windows open or are they not? Where in Fieldbus communication and BMS integration, usually you're doing that because the building management system wants to know a lot more about the motorized windows. And integrate that knowledge to be able to say, okay, well, mechanical system, you shouldn't be working right now, or whatever it is a DOAS system or a VRF. So there's lots of different options there for you guys. But I think that's it, Laura. We are right on time.
On time, and yeah, really great questions and great input, Mia. Thanks.
No problem. Did I miss any other questions? I don't think I see any. Let's see here. Open this guy up. I think that's it, guys. Thank you so much, everybody, for tuning in. Again, we'll send the slides in the recording hour. I really appreciate your time and your attention today and your thoughtful questions. So hope to see you next time. More content coming, and thank you so much, everybody. Bye.